Okay, so good afternoon, everybody. If you haven't seated, please sit down now. We're going to kick off the second part of today with my talk on the treacherous road towards multi-DNS. My name is Daniel Mittelman. Just a few words about myself. In my current position, I'm an infrastructure engineer at Monday.com. I used to be an analyst, turned developer, and eventually went into DevOps and stayed there ever since because it's awesome. And I've been hoarding certifications for fun for the past few years. Not because it's any requirements of some sorts, but I found out that if you want to learn a new subject and you actually want to persist, then you should build a structure and a timeline for yourself. So I learned that the best thing to do is just to commit to doing a professional certification. You don't even have to go to the test. You just need to persist with the certification. So this is my tip to you. So a few words about Monday to preface what I'm going to talk about in the next 39 minutes is a few things about Monday. So Monday is building a team collaboration platform. There are a few images on the right that shows you how the application looks like. We've grown in about 6 or 7 years from 0 to 350,000 weekly active users that are actually paying for the service. And our customers are mostly in the US and in Europe. I've been in Monday for 3.5 years, and I have the pleasure of seeing a company that grows 10 times. So I've tried to bring a proxy to explain to you better how that looked from our side. So I took the number of monthly user interactions that we have with the platform, and I discovered that no matter what year you start from, it always looks the same, like this exponential spike. So it is awesome, but I hope that it allows me to explain the amount of challenges in terms of scale and reliability and availability that we deal with on a daily basis. But I think that the most relevant number for you at this stage is that we have 250 million DNS queries every month made by our customers to find our own service. Now, 250 million DNS queries per month is a lot for a company the size of Monday. For a company 10 times the size of Monday, this is still a lot. I'm not going to go into detail why we use DNS so massively, but I just wanted to let you know the type of challenges that we deal with DNS. Now, this is not any different from any of you that have a public-facing service, but this is something that is especially sensitive for us. And this is why we have to treat DNS very, very carefully. So just a quick network overview of what happens when a user tries to access Monday. And I'm going to say at this point that we use Cloudflare. Now, just by show of hands, who here uses Cloudflare or Akamai or Reblaze or any of the other alternatives? Okay, so quite a few of you are using it. So you might be familiar with this type of network topology. So whenever a user wants to access our application, they would first perform a DNS query, I mean, not them, but their browser on their behalf through the operating system, to find the IP address behind the domain. So first of all, the computer would perform a DNS query. It would go to the ISP or any other recursive DNS name server that is configured on their computer, and it would then recursively try to resolve the IP addresses. So if you're just using basic DNS, this would be resolved to your own load balancer or external service. In our case, because we use Cloudflare and because all of the traffic is routed through Cloudflare's edge network, it is not resolved to our own network. It is resolved to two Anycast IP addresses that represent their edge network. So this IP address would then lead the user to the closest Cloudflare point of presence or the closest server on the network that would allow communications to be with the lowest latency as possible. From that point, Cloudflare would then perform TLS termination, and that would allow them to do all the things that they provide for you as part of being a network security perimeter service. For example, DDoS mitigation and a web application firewall and rate limiting and content-based routing and content-based filtering and a whole host of other services that they offer. They would then re-encrypt that transit and would then send it to our own backend. And that would in turn be routed to an EC2 instance or a Kubernetes workload or a Lambda function. It doesn't matter. The most critical part to understand at this point is that all of the traffic is routed through one of Cloudflare's points of presence. So we've worked like this for a year and a half, and this is actually what's called a best practice. I mean, when you sign up to Cloudflare and when you try to integrate their service with your application, that's how they tell you to do it. They tell you, go to our management console, type in all of your DNS records, let us handle DNS for you, and we will then resolve all of your queries to wherever they needed to be resolved. And actually, if you sign up to one of their lower tiers, their free or their business tier, this is the only way they're going to let you do it. So this is not an unusual setup. So we have worked like this for a year and a half, and everything was great until July 2nd, 2019. And this is where our story begins. Because if this had worked until today, I would have nothing to talk to you about. So July 2nd, and I still remember this day very vividly. It was a Tuesday. It was around 3 p.m. And we were at the office minding our own business, doing our things. And 3 p.m. is usually when inbound traffic starts to go up, because most of our client base is in Europe and in the US. So 3 p.m. is around 7 a.m. in the East Coast. And this is when people would start waking up and like opening the mobile app or opening our application on their web browser and like look through their agenda or their project. So this is how it would look like from their side. From our side, if you were a Monday.com load balancer, this is how incoming traffic looks throughout the day. So 3 p.m. is roughly around the time when we start to see traffic increase. It was a Tuesday around 3 p.m. We were sitting at the office, and suddenly we get a text message and a phone call and a push notification from PagerDuty letting us know that the homepage is down. Now, the homepage for us is a critical asset because we invest a lot in online marketing and it is the face of our company, but it's still not the application, so it's not that bad. So did we panic at this point? Well, no, because this is something that we can probably fix. Naturally, a few seconds go by, and we are bombarded with SMS messages and phone calls and PagerDuty notifications letting us know that everything is down. So the application is down, and the blog is down, and something we have called Monday Stories is down, and other external services that we have, everything is down. So naturally, we scramble to our computers, and we open a web browser, and we go to Monday.com, and we hit the Enter key, and we see this. So this is not something that you want to see when you're in your production environment, especially when it's peak time. But we saw the little word that said Cloudflare at the bottom, so we knew that this 502 came from Cloudflare. So we didn't panic at this point, because we know that sometimes in extreme cases, Cloudflare might have a problem with one of their points of presence, and they can reroute traffic automatically. So in extreme cases, they're not able to do this. So what we can do instead, we can go to their management console and turn off the reverse proxy capabilities. So this is what we fondly call the orange cloud. So for every DNS record, you can choose whether you want to proxy it or not. So if they have a problem with their network, we can just go to the management console, type click on the orange cloud, turn it into a gray cloud, which means that reverse proxy capabilities are off. So DDoS is off and WAF is off and everything is off along the way, and then our DNS records would be resolved directly to our VPC, directly to our load balancer. So we are giving up some security capabilities, but it's much better than like being down. So we weren't panicked at this point, and we realized that this is all we had to do. So we went on the Cloudflare.com website, and then we realized that not only is their entire network down, but their website and their API are also down because they use the same network to route traffic into their website. So we realized at this point that everything on our side is up. Like our load balancers are up and the application and our Kubernetes workloads and everything is up, except for the fact that Monday.com is globally down. and there is absolutely nothing that we can do about it. So we started thinking naturally, what can we do? So how about we delegate our DNS to another provider? But that takes hours or even days, so we're not going to do it, especially if this is going to be resolved in a few hours. So we sat down and we realized that there's basically nothing that we can do, and we just sat down at the office, looked at the screen, and waited for Cloudflare to regain service. And indeed, after 27 minutes, the issue was fixed, and our application was partially available, and it took about 2 hours to regain full availability. So we stopped at this point, and we said to ourselves, well, we've done everything so far according to industry standards. We've done everything according to best practice. And still we were down. So basically that means that something in this process is wrong. And so we sat along with ourselves and we thought, okay, so if we were to draw a new industry standard for ourselves, how would it look like? And then we decided to agree upon 3 axioms. So the first one is the DNS and reverse proxies should be managed by different providers and must be hosted on different physical infrastructure. It might sound a bit banal, but actually if you work with Cloudflare or Akamai or some of their competitors, there is a high chance you're not doing that. And I hope that my little story explained why this is true. The second one is, and this is something that all managers of DNS servers know by heart, is that DNS networks are constantly under attack. Just go to Google and type in DDoS DNS. You will find a host of stories from recent years speaking about DNS networks being down because they were targeted by a DDoS attack that took them even days or even weeks at a time. And this means that if the network is down, you are down because your authoritative DNS servers are also down, so no one can find you. So we agree on those 2 things. And one little thing that I wanted to add, which is axiom number 3, is that DNS is key. You can go ahead and you can build your multi-AZ, multi-region, fault-tolerant, redundant, resilient, whatever you want to call it, infrastructure within your own cloud provider or on-premise deployment, whatever you use. But as long as DNS that points your customers to your application is down, it doesn't matter how much effort you put into your own infrastructure. If DNS is down, you are down, and your customers doesn't care. Your customers don't care why you're down. For them, you're down because you haven't done something right. So we've built a proposed plan which is built on those axioms. And the first one is to move DNS to a different provider. This is based on the first axiom that we want to separate reverse proxy from DNS. The second would be to introduce a second provider for redundancy because, again, DNS networks are constantly being attacked, and profit. So I'm going to get into more of the technicals now, but before then, I want to introduce the main term that we're going to talk about, which is multi-DNS, which simply means an architecture that utilizes authoritative name servers from 2 or more providers. So you take multiple network providers, multiple DNS providers, and you use multiple at the same time to ensure that you're always up even when one of them is down. Now, DNS providers usually incorporate multi-region, multi-AZ. They incorporate that because they know they're going to be attacked all the time. So when you register with a DNS provider, it can be Route 53 or it can be Cloudflare themselves. It can be any of the other dozens of DNS providers out there. You usually get a set of name servers. And this is because they rely on the fact that at some point one of them is going to be down. So this would allow them to have internal redundancy and allow you to enjoy that as well. But what happens if the entire network is down? Because if someone chooses to target a DNS provider as a whole, they're going to target all of those name servers at once. They're going to attack all of them at once. So if they're targeted, everything is going to be down. Using multiple providers allows you to ensure that even if one of them is down, you still have enough name servers that should be up to enable you to keep your availability. So we haven't invented multi-DNS. There are lots of companies that are already doing this with their own infrastructure. So if you look at Airbnb and Adobe and Spotify and even Amazon themselves, you will see that if you perform a dig-ns command on your computer that would resolve to their NS records, you will see DNS providers, multiple DNS providers within their list of name servers. So if you want to probe like one website and see if they're already implementing multi-DNS, you can just run this command at the top and you can see if they are doing it. If you do dig-ns on monday.com, you will see, of course, 2 providers. So there are multiple strategies to implement multi-DNS. I'm not going to go into all of them. I will go into the third and last one of them, which is the one that we've gone through eventually, which is called primary. And in this configuration, whenever a customer of yours wants to resolve your hostname through the DNS network, they would send a DNS query, usually to their ISP or whatever DNS server is configured on their network or on their computer. And that in turn will recursively look for the authoritative name servers. And if you have multiple name servers from multiple providers, one will be chosen at random and will be queried. So if one of them is down, it would just go through the list until it finds a live one that would respond. So this configuration allows us to ensure that, first of all, you have multiple providers, but second of all, they are completely unaware of one another. So one provider cannot influence the second one in any way because they are completely oblivious to the existence of the second one. Now, if you want to update a DNS record in this configuration, it is your responsibility as the admin to go to both providers, go to that DNS record, and then update it manually. Now, while this approach has many pros, it still presents a very significant challenge, which is how do we keep 2 DNS providers that, as I said, do not even recognize the existence of one another? How do we keep them in sync? How can we ensure that we are never having any discrepancy between the responses returned from those 2 providers? Or, if we rephrase, how can we establish a single source of truth? So that is a question that we were presented with when we built this strategy. And of course, I'm going to answer it in a few minutes. So I'm glad to share with you all that we have done this migration. We have moved to multi-DNS. We have moved out of Cloudflare as a primary DNS provider and moved into multiple DNS providers. In our case, we've used NS1 and Constellix, but this is relevant to any multiple DNS providers that you may choose to move your architecture into. And we have summarized, I think, the most key elements of the migration into the 5 principles of the successful migration to multi-DNS, which I am happy to share with you today. So the 5 principles are sync your team and restrict manual updates, use Infra-as-Code tooling for zone management, create your own recursive DNS test server, create a playbook for the migration, and perform a dry run test in a test environment. We're going to go into each and every one of those now. So the first one is to sync your team, which might sound a bit obvious at this point, but if you have multiple entities within your company or within your team that are performing DNS updates, it's crucial that once you start your migration, you keep everyone at sync and you ask them to perform those changes through you. Because during the migration, you might have multiple DNS providers live, and you need those updates to be consistent across all of your providers. So everyone needs to be aware of the changes that you're making, when you're going to start, and when they're going to end. And once everyone is at sync, you can even take it a step further and restrict manual updates. So just go into the DNS provider that you're using and just take away everyone's permissions. This might be the easiest way to do it. And again, ask everyone to perform all the changes they need through you. Now, this applies to both manual changes, and of course, it applies to automatic changes if you have automated processes that perform DNS changes. For example, if you have a blue-green deployment that uses DNS to redirect traffic between the blue and the green team, the blue and the green group, then just keep in mind that any change that you make to your existing DNS provider must be reflected within the newer ones that you're going to transfer to. So that little thing that you used to do until now, if this is how you used to manage DNS, so don't do it anymore. The second part is to use Infrastructure-as-Code to manage DNS. And this is a big one because we have all, or hopefully most of us, have done this process with how we manage infrastructure. I assume that most of you are using Terraform or Pulumi or CloudFormation or any of the other available tools out there to manage your infrastructure in a reviewable and an auditable and a traceable way. So Terraform does have a few very good providers with integrations with major cloud providers and other ones as well. Pulumi does work well with major cloud providers, but we were looking for something a bit more specialized. So we went on a hunt and we found Multi-DNS, which is a relatively new open source tool that you can find on GitHub that is built on a very simple premise. You have a single source and you have multiple targets. And Multi-DNS is the component that stands in the middle and allows you to make sure that one source of truth is always reflected into your multiple targets. So on the left, you select your source of truth wherever you want to manage your DNS records. It can be another DNS provider if you want to perform a live migration from one provider to another. This is something that I don't recommend that you do. Other than that, you can use a YAML file to manage and list all of your records, or you can even use a bind zone file or a bind compatible DNS provider. So you list all of your records in one single file, you plug it into Multi-DNS, and then you define your targets. Now your targets can be a single DNS provider, it can be multiple DNS providers, or for some reason it can also be a YAML file because we all love YAML. I'm just kidding. So a few good things about Multi-DNS. So as of today, it supports 16 different DNS providers. So you basically have a free choice of what DNS providers you want to work with. It of course supports the major cloud providers. You have Route 53, you have the DNS of Azure and of Google, and you have a whole host of other providers as well. The way Multi-DNS works, and this is if you've worked with Terraform, for example, it works in a very similar way. It computes the diff between the source that you have defined with your targets. Now, if your targets are out of sync, that diff is going to be different, but it doesn't matter because Multi-DNS will compute the steps required to perform on each of your providers separately to ensure that at the end, those two providers are completely in sync with the source that you have defined. So if for some reason someone goes into one of the management consoles online of one of those providers and performs a manual change, you can use Multi-DNS to detect that change, and you can align those two providers, or even more than two, to your defined source of truth. And of course, as any Infra-as-Code tool, your zone file can be committed to source control. It can go through all of the procedures that you're doing on source control now, like code reviews and auditing and histories and reverts. Everything that you gain from working with IAC today, you can get from DNS as code. So here's an example of how a zone file for Multi-DNS might look like. So you recognize the familiar YAML structure. So in this example, we have two subdomains. The first one is the zone apex, which is the monday.com part. And in this case, we have set it to use a Cloudflare distribution. And the second part is the email subdomain, which has two different records. One of them is an A record that might serve a static web page or an application. And the second one is the MX record, which would allow you to use that subdomain as an email provider. So a few good things to look at when looking at this file structure is the first one, you can use comments like any other YAML file. I don't know if you've ever received a zone file or a DNS zone from someone else, but when I started working on the DNS of monday.com, which was managed for many years back into history, we've had about 95 records, and I think about 80 of those I did not recognize. I had no idea why they were even there, who was responsible for them, and whether I can remove them safely when performing the migration. Now, 90 records might be a lot. For others, it might be very little. I assume that some of you might have dealt with zone files or zones hundreds of records long. So using comments allows you to explain exactly why this DNS record exists, who placed it there, and if it should be removed in the future because it might belong to like a temporary migration or something that is irrelevant from some point in the future. And of course, if you use source control, that you can also use a commit message. The second part is that the source file of OctoDNS groups records under the same subdomain. So if you have multiple records of different types that belong to the same subdomain, OctoDNS will automatically group those under the same subdomain. So it is much easier to look through. And the third part is that because OctoDNS is a specific tool for managing DNS, you can have vendor-specific features. For example, in this example, because we're still using Cloudflare to protect our environment, you can have a specific annotation to tell OctoDNS to control whether that record is going to be proxied or not. So that's pretty cool. The third step is to build your own DNS testing server. So a DNS migration might be based on taking a set of DNS records and taking them from provider A to provider B. So by copying the records into a new provider, we naturally assume that everything is going to move the same way and the new provider is going to work exactly the same as the previous one. But how can we prove it? Because, for example, if you use Cloudflare or Akamai or some other DNS provider that incorporates security features into their set of services, then you might not get the exact same response that you expect when you perform that query. One example might be DDoS protection. You do not get the exact same IP address because you're redirected to the edge network rather than your backend. Other examples might include HTTP to HTTPS redirection, which you might receive a different response than you may expect. And there are many other use cases that you might not receive the response that you expect to receive when querying your DNS provider. So we need to find a way to prove that once the migration is done, then everything is going to be fine and we're going to get the same response as we did before. So we thought about it, and the best way that we could find to prove it is to build our own custom recursive DNS server, and that part takes about 5 minutes. So we're gonna dive into that for 3 minutes, and it's really much easier than we had thought initially. So what we want to simulate in this part is to create our own new recursive DNS server that you can set up on your computer. Your computer would continue working just fine. So if you perform a DNS query to find a site like CNN.com or Google.com or any other website that is not related to your migration, then that DNS would recursively ask another DNS server like 8888, which is Google's public DNS service. But if we were to query our own specific domain, I don't want to get the response that I would have gotten from my old provider. I want to be redirected to my new provider and simulate a situation where the migration is already completed. And in that way, I would then require my DNS server to use the upstream server that is my new DNS provider to get the response. And using that, I can actually use that on my computer or configure that in core DNS, for example, if you use Kubernetes, or just set it up on a bare bones server and see what type of responses you get and whether your application keeps working after the migration is done without you actually having to delegate your domain to the new provider. So to do that, all you need to do is just a few steps. You launch a VM, you install Bind9, which is an open source project that is used to build a DNS server. It's a very popular way to implement DNS servers. And you need to remember to open 2 ports, of course, 22 TCP for SSHing into your machine. And you need to open port UDP53, which is the port that is used to perform DNS queries. Once you've done those 3 steps, all you have to do is just mildly change the default configuration of Bind9 to achieve exactly that behavior that we want to achieve. So we said that we want one global behavior that acts like any other DNS provider, except for one single domain. So to the left, you configure the global configuration file, and you need to list 4 directives. The first one is listen on port 53 any, which means, hey DNS server, please listen on port 53 on all interfaces. Allow query from anywhere around the world. We define a one forwarder. You can use 8888 or you can use any other forwarder that you want, as long as it's a fully functioning DNS recursive server. And we enable recursion because we want to use this like any other normal DNS server. Once we've done that, we need to add a new zone, which is only like 4 lines. So we define a zone for our domain. In this case, it's monday.com. We define it of type forward, and we defined a whole set of other forwarders for this domain. In our case, it's 198.51.44.7, which is one of the name servers of our new DNS providers. In that case, it's NS1. I'm gonna say at this point that you don't need to remember everything that I'm showing right here. This whole talk is based on a blog post that we've published a few weeks ago on our new engineering blog, the monday.com engineering blog. So you can just go online after this talk if you're interested and read more in depth about how to actually perform the migration. So the fourth one is to write a playbook, and this is a less defined step because each and every one of you might plan a different migration using different providers. You might have a different environment, and you will need to construct your own playbook, which is defined on how you work and how your infrastructure is currently set up. But the most key element that I wanted to convey at this point is that it's imperative to have a written plan with clear checkpoints and a point of no return. And this is not relevant only to DNS migration. I think that this is a key value to remember for any major migration that you perform on your production environment. So specific to DNS migrations, there are a few key things that you need to remember and hopefully incorporate into your playbooks. So the first one is that your first checkpoint must be aligning your old and your new providers. So we've said that just moving those DNS records from one provider to the other might not achieve 100% the outcome that we're expecting, because you might have things along the way that are changing those DNS responses, especially if you work with a DDoS mitigation provider like Cloudflare. So make sure that you've aligned 100% your old and your new provider, and you can do that either with dig commands, or you can use the custom DNS provider, the custom DNS server that we have built for this purpose. It's going to give you a full simulation of how your migration is going to look after you've performed the delegation without you actually having to do that delegation for testing. The second thing you need to remember is that the default TTL of NS records, the records that represent which DNS name servers are the authoritative name servers for your domain, is 48 hours. So that means that once you've kicked off your migration, if you have something wrong in production, you're screwed, because it's gonna take you a long time to recover. You will need to redelegate your domain to your original provider, and in that case you might have some providers global that have already propagated and have already stored your new values, and it's going to take them 48 hours to recover or to refresh their cache. So you must be able to first align your old and new provider, and you need to remember that TTL takes 48 hours. So it's not a recommendation, it's not up to 48 hours. This is what I'd hoped for initially. This is a hard line. You need to wait at least 48 hours after you perform the change in your DNS, it's mostly register, before you perform the next steps of your playbook. The third thing, which I highly recommend, is that you monitor the propagation progress of your new DNS records. Now, there are a few websites online you can use. One of them is called DNS Checker, but there are multiple ones. I highly recommend that you use multiple ones, because each one of those websites can query a different set of servers. This is how monday.com, for example, would look like when you go to DNS Checker. You need to type in the name of your domain. You need to select NS as the type of record that you want to query. You click on search, and then that website would perform multiple DNS queries to multiple DNS servers around the world, and you will be able to see the actual progress through which the propagation of your new records is going through. And of course, this will take 48 hours. You will see that the most of the change happens in the first 2 or 3 hours, but you need to be patient and you need to wait until you have full propagation before you complete your migration. And the fifth one is to dry run this on a test environment, especially if your production environment might look something like this. Fortunately, this is not how the Monday.com infrastructure looks like, but I do realize that there are some companies that have very complex environments that may have been like this for years at a time. So you need to, before you actually start to perform the migration, you need to take a step back. If you have a test environment that you can use to perform that migration before you start working on production, then please do. If you have a different domain name that is used for your QA or your staging environment, then do this whole process on that environment first. Create a custom DNS server. Do all the checks that you need to do on that environment, wait the 48 hours, and then do all of the post checks that you need to perform before you actually start working on your production environment. This will save you a lot of unseen problems that might arise during that migration that you had not anticipated when you first planned this. And again, once you start the DNS migration in production, if you have something that has gone awry, you will have some problems for up to 48 hours. So it's super critical that you take your time, you plan, you perform the testing wherever is needed. And then only once you have gained enough confidence to perform the migration, only then do you delegate your domain to the new authoritative name servers. So just to recap, so the 5 key things to do when you plan a migration to another DNS provider or to multi-DNS. So the first one is to sync your team, make sure that everyone's aligned, and restrict manual updates to make sure that no one creates discrepancies between your old and new provider or your new provider number 1 and new provider number 2. Use Infrastructure-as-Code tooling for zone management. I highly recommend Okta-DNS, but if you want to use Terraform or another tool, go for it. Just stick with managing your zones like this from now on. Otherwise, you will find some discrepancies along the way that you had no idea where they came from, and then you find out that someone just did a little change because they needed to do something and they forgot that they needed to use that tool. Create your own recursive DNS server. This is a very effective tool to ensure that you do not have any discrepancies you're not aware of, and it might give you a lot of confidence before you actually perform the production migration. Create a playbook for the migration, and of course, dry run it thoroughly on a test environment. And that's it. So thank you. Sure.
So how many name servers have you, for example, have got on the DNS records? Mm-hmm. How many? 6, 7? I don't.
So one of the considerations we had when we integrated 2 providers was how we wanted to split traffic between them. We have our primary one, which is NS1, which is in our opinion, a more robust and a more advanced DNS provider than the second one. So what we've done, we've placed 4 name servers from NS1 and 1 name server from the second one.
What happens if one is under attack? Mm-hmm. Is there any latency, or how does the resolving goes?
Okay, so if one of your providers is down, let's say that you have a 50-50 split between those 2 providers. If, let's say that you have 4 name servers from provider A and 4 name servers from provider B, either your computer or the recursive DNS name server that you're using is going to try to resolve from a random one. If it is up, then you're going to get the response immediately. If it is down, it is based on the software that is actually running on that DNS server. If I remember correctly, the most common timeout is 1 second. So it's just going to try for 1 second, and then it's going to hop onto the next until it finds a healthy one. So you might feel a few seconds of latency, but your site is going to still be up and running. Okay. So that's all the time I have for questions. If you have any other questions, I'm going to be around, so just feel free to approach me. And thank you.